Okay, our next example, kinuha ko din sa module din natin, ano? Sa number 2 yan, ayan sa may sample problems. Okay. Resolve vector A. This is vector A in its Cartesian vector form into two vector components. One parallel to and the other perpendicular to vector B. Ito yung vector B in its Cartesian vector form. So express each of your answers as a vector. So express daw natin yung answer natin in Cartesian vector form. Okay? So, yun. So una, kunin muna natin yung parallel. The parallel component. So parallel siya sa vector B. So anong kailangan natin? Let's say letter A muna tayo. We need to find the component of vector A parallel to B. So let's say ang ginamit na notation sa module natin for the parallel component is AT. Okay, so yan. So AT is the component of vector A along the line of action of vector B. So this is simply equal to vector A times yung ating unit vector along the line of action of vector B or force B. Let's say n sub B. Okay? So A in Cartesian vector form. Given naman na yung Cartesian vector form ng A, so wala tayong problema. Ang problema na lang natin is the unit vector B. So how do we solve for the unit vector B? So NB is equal to yung position vector natin, R, divided by yung distance between the 2 points. So, pero wala naman tayong given na points, ano. So, how do you solve for the unit vector along the line of action of B? So, ang given sa point B is its expression, equivalent expression in Cartesian vector form. Okay, so we can use that to solve for the unit vector. So ang gawin natin, di ba yung position vector natin, we can define also the position, the unit vector in terms of the Cartesian vector form of the force. Okay, so paano yon? We are going to follow still itong concept na ito. Ang gawin lang natin, we need to solve, we need to identify yung Cartesian vector form ng force, in this case, vector B or force B, divided by yung B. Dapat B ito na naka-red. B in Cartesian vector form, tapos divided by B na single force, yung resultant niya. So di ba itong B na given naka Cartesian vector form, ibig sabihin ito yung mga components niya along x, y, z axis. So ang gawin natin, we're going to resolve itong components along x, y, z axis into a single force, which is now the resultant force natin, in this case capital letter B na ito. Okay, so we can also express, again, we can or we can solve for the unit vector in terms of the Cartesian vector form of the force and its resultant. Okay, so given naman na yung ating, hope that is clear sa ating medyo blurred. yung focus niya. Oh no. Ayan, okay. So given naman na yung Cartesian vector form ng ating force, so that is 4i plus nandun sa module natin is, so wala siyang y component. So 0j plus 2k. So 0 yung ating value ng y component natin. So all of these are in kilonewtons divided by yung resultant natin. So how do you solve again for the resultant? So yung resultant natin is simply distance formula. Pythagorean theorem. We have 4 squared plus 0 squared. The square root of the quantity 4 squared plus 0 squared plus 2 squared. So our unit vector along the line of action of B is equal to, so simplify na lang natin ito. Ano. So we have 4i plus 0j plus 2k divided by, so that is by 4.472. Ayan. So our unit vector is equal to 0.894i plus, of course this is 0j plus 0.447k. Okay, so yan na. So meron na tayong A in terms of Cartesian vector form, expressed in Cartesian vector form, and we also have the unit vector along B, vector B. So pwede na tayong mag-perform ng dot product. So AT or A tangential, tawag natin dyan ay tangential, is equal to we have A is 6i minus 4j plus 5k in kilonewtons. That yung unit vector natin is 0.894i plus 0j plus 0.447k. Okay, so yung ating A tangential or yung ating force, component of force A along the line of action of B is equal to, so i-multiply ulit natin itong mga to. We have 5.364i. So, negative 4j times 0, so 0 na yan, plus 5 times 0.447, that is equal to 2.235k. 80 natin is i-add lang natin ito. So, 2.235 plus 5.364. 7.599, so that is basically 7.6 yung ating component along component of A along the line of action of B. So A tangential natin. So 80 natin is 7.6 kilonewtons. Okay, so yan na. But take note, we have to express yung answer natin in Cartesian vector form. Okay, express each of your answers in as a vector, or it should be in Cartesian vector form. Alright, so how do we do that? So how do we express AT in Cartesian vector form? Okay, so paano natin expression in Cartesian vector form? We simply multiply. So 80 in Cartesian vector form is equal to, let's say equal na lang natin. I-read na lang natin to differentiate. 80 in Cartesian vector form is equal to yung force natin, yung magnitude natin na 80 here, times or dot yung ating unit vector along B, which was solved a while ago. Ito yung ating unit vector. So that yung 80 is 7.6 kilonewtons times dot tuloy. Dapat times pa na to, sorry. So scalar. Ayan, times unit vector natin. So we have 7.6 kilonewtons times yung unit vector natin na ito. Okay. So we have 0.894i plus 0j plus 0.447k. So we have 6 point, solve natin, wait lang. So 7.6 times 0.894. 6.794. Correction kanina, this is not that product, but this is a product of ito at yung ating unit vector. Okay. So, distribute lang natin dun sa loob. Okay. So, we have 6.794 I. 7.6 times 0, so 0 yan. We have 7.6 times 0.447. That is 3.397. Okay, so this is in kilonewtons. Okay, so this is the answer for the first part, which is ito yung ating component of vector A that is parallel to vector B. So line of action ng vector B. Okay. Paano naman kapag perpendicular? Sir, paano kapag perpendicular? How do we solve it? How do we solve the component kapag perpendicular? Kasi sa previous na examples natin, palaging parallel or along. Yung along tsaka parallel, parehas lang yan. Kasi kapag parallel, yung isang force sa isang parehas lang yung slope nila, parehas lang yung direction. So when we say parallel, if you're solving for the component parallel to a certain axis or to a certain force, it's just like solving for the component of that force along that axis or along the line of action of that particular force. Okay? So next is, how do you solve for the component perpendicular? So paano naman kapag perpendicular yung ating solve the component? Okay, so how do we solve for the component parallel to B? So paano ba explain yun? Let's have a very simple explanation. How do we do that? No. Paano ba natin gagawin? In 2-dimension na lang para mas madali natin maintindihan. For example, yung meron tayong vector. So sa problem na ito, we have 2 vectors. For example, yung vector B natin is directed pa ganyan. So this is B. Tapos yung A natin is pa ganito. So this is vector A. Okay? So this is vector A. Sorry, my voice. So kanina we have solved for the component. This doesn't itong figure natin ay hindi ito yung yung talagang location or yung representation ng mga vectors. Okay, this is just to explain paano natin kukunin yung perpendicular na component ng force natin. So we have, as for example, we have a force B, ito yung direction niya, and we have a force A here, ito yung direction. So if we solve for the pag sinolve natin yung component of A na perpendicular, na parallel sa B. So for example, ito. This is A. Na parallel siya sa B. Okay. And then, so ito yung, parang ito yung ginawa natin kanina. We have solved for A, the component of A that is parallel to B. So how do we solve now for the component of A that is, ito yung AT. Yeah. That is perpendicular to B. So perpendicular to B, ganyan. So perpendicular siya sa AT, of course. So let's say this is AN. Yan. So if we are solving for the component of A that is that is perpendicular to B, then that component is also perpendicular to AT. Okay, so nakita niyo na. So that if this is A, let me see. If this is A, so if you resolve the resultant of AT and AN, okay, if you solve for the resultant of AT and AN, that should be equal to A. No. So which means that when kapag nag-add tayo ng vectors, when we add AN and AT, that should be equal to A. So that is now equal to, so A is equal to AT plus AN. Okay, so the resultant of AT and AN should be equal to A. So how then can we solve now for yung force natin that is perpendicular to AT, yung AN natin? So we just need to manipulate itong equation natin na A is equal to AT plus AN. Okay, which means that to solve for AN, lipat lang natin, that should be equal to A minus AT. Okay. So A minus AT. That's how we solve for AN here. Or the force or the vector that is perpendicular to the line of action of vector B. So I hope klaro yon. I hope klaro. Kung saan natin kunin. So again, if this is force A and we have solved for the component of A that is parallel to B, so ito yon. And we are required to solve for the component that is perpendicular to B. So dapat yung component ng A na perpendicular sa B, that means perpendicular din siya sa AT. Parang ganito. Okay. So nakita nyo yung parallelogram dyan. Okay, so that if we resolve AT and AN into a single force, that should be equal to A. So add tayo ng vectors. A should be equal to the resultant of AT and AN, or that is equal to AT plus AN. Now to solve for AN, yung sinusolve natin na perpendicular siya sa B, at sa AT, so manipulate lang natin ito. So AN now is equal to, ilipat natin itong AT sa right, sa my left side. So AT AN is equal to A minus AT. That's yan yung ating working equation now to solve for the component of A perpendicular to B. Okay, so let's do that. Okay, so letter B, solve natin yung component of A that is perpendicular to B. So we are solving for AN from my previous explanation. AN is equal to A minus AT. A is already given. So ano natin yung A dito sa problem. Ayan. Ito yung A natin. 80, alam na ba natin? Ito yung 80. Okay, so madali na lang natin isolve ang AN. Okay? So let's do it. So AN is equal to, we have 6i minus 4j plus 5k minus 80, which is 6.794i plus 0j. Lagyan natin yung 0 para hindi kayo malito. Yung mga iba kasi sa inyo nalilito. Kaya ilagyan na natin. Although wala talagang value yung walang y component. Okay. Plus 3.397k. Okay? So ito na yung an natin. So, combine lang natin yung like terms. So, take note, this is subtractive, hindi siya dot product. Subtract natin. So, combine natin yung mga like terms. Like terms. So, we have 6i minus 6 point, may point dyan, 794 I. And then minus 4j minus 0j. Then plus or minus, parehas din naman, plus we have 5 minus, that's weird. Yep, minus 3.397k. So we have minus 0.794i minus 4j plus 1.603. Okay. So this is in kilonewtons. Okay. So this would be the component of A that is perpendicular to the line of action of force B or vector B. Okay? All right.